University in London. And the title of my presentation is Myo Tracker, a mobile application to monitor and determine muscle strength in real time. So just to go systematically, just tell you the brief of about this research, the background, and why we decided to embark on this. So the use of wearable sensors in clinical assessment has gained so much attention, and EMG sensors are used to be able to measure muscle signals and be able to diagnose neuromuscular diseases such as muscular atrophy, myopathy, and neuropathy. The problem existing right now is that these sensors in the open market are very expensive and may not easily be available for individual to use. And also, some researchers have attempted to design low-cost EMG sensors, but these sensors have not been able to adequately couple and monitor the muscles of patients in real time. So with this problem, we sought to try to see how we could fabricate a simple low-cost EMG sensor that's able to couple with a monitoring on a mobile app, allow users to determine the muscle's strength in real time. So the aim of this study was to design a Myo Tracker, a mobile-based EMG sensor with an Android app that allows you to monitor and display the strength of a muscle in real time. So we try to see how we could eliminate this issue of the sensors being expensive and not easily available for use. So because the presentation said that it was just 10 minutes, so I just try to summarize it and go straight to the meat of the research. So this was just the architecture design of the low-cost EMG sensor. So what we try to do, we try to fabricate this EMG sensor. So we use the surface EMG sensor, the malware. We had a power source. Then we use the Arduino Uno, a Bluetooth module. We use the STU 05 Bluetooth module, and with our mobile phone here. So what we try to do was just see how we could program the Arduino Uno to connect with the malware and the Bluetooth module to provide it with some form of connectivity, allow the user to measure the muscle signals and view it in real time. So this is the main thing that the prototype of our proposed design, the hardware components of the low-cost EMG sensor. So here we have the malware, the tool that allows you to be able to measure the muscle signals. So this one we bought it for £5 here in UK here. Then the Bluetooth module as well, just £2. So it has certain features that allows you to be able to measure the muscle. So you could see the parameters here and the range for which. So let's say the operating voltage, 3.5 volts to 5 volts, and the price here. Then here to the Bluetooth module is saying that here with a certain range, you can be able to connect it to the mobile phone app and you to measure muscles. So this was just the fabricator. I must say that this is still in the research process. So we've done the prototype. The next thing is to try and see how we could be able to manufacture in the real life. But we did a testing of it. So what we did for this one, we tried to see how we could test it to see if it actually works and if there are any issues. So what we did was we tried to calibrate it with the standard base. So this is an example of a standard base EMG sensor. That's the trigonal advantage sensor. So this one costs over more than £10,000 here in the UK here, and this is very expensive. And one of the main aim was to try and see how we could to fabricate a low-cost EMG sensor that be able to measure muscles, perform the same functions as the standard base EMG sensor. That's very expensive. So it's in that this here is the standard base trigonal advantage sensor in the open market, which is expensive. So what we did after manufacturing of the prototype from what we got from our low cost, we tried to calibrate it and so we recruited 3 individuals patients. So we tried to put the 2 sensors together and allow them to perform some form of activity to be able to determine the muscle strength in real time. So in designing, the first we designed the hardware. The next thing was to design a mobile application. So the mobile application called the Mayo app is what allows you to be able to monitor the models in real time on what a mobile phone. So we designed what a mobile application using what Android Studio here and Java language. And what the thing was just a simple user interface that has 3 buttons, allow the user to be able to view the model signals that is being measured in real time. Then it with 3 buttons to be able to start, connect to the hardware base, and be able to view the signals. So here, the Mayo tracker allows the user to be able to visualize the EMG signals from what the micro base sensor via the Bluetooth. So this was what we try to do here. So you can see this next slide here. So this is the interface of what the design, the Mayo app, that connects to the hardware component. Now, in trying to determine model signals, you look at the 3 main components that allow you to determine the strength of a model, such as the mean absolute value, the root mean square, the mean frequency, and what the maximum voltage contraction. So what we did was that we attached these 2 systems in the arm workout, allow the user to be able to lift some form of lightweight to be able to determine the model signal. Now we set parameters. Now, one of the novelties that we are introducing this was that we try to see, introduce some parameters to see how we can to determine what the model strength. Now, I mentioned that here, the mean absolute value, the maximum voltage contraction, and the mean absolute, the mean frequency that we use. So for weak model signals, we're saying that here was the average amplitude between 0.1 millivolts to 2.5 millivolts. Then for strong here, now we said that set the parameters for 2.6 millivolts to 5 millivolts. So this was the main app itself here. So the user have to be able to connect to the hardware-based EMG sensor via the Bluetooth. So upon connection, then they could start to read the model signals. And reading this way here, the graph just displays the signals that are being recorded from the models here in the single in the window. So you could have in the window here, and you're saying that the EMG values in time in nanoseconds. So there are here various options in which the user could do pivot to view the report, that is the model signal that's recorded, export it, that's the model signal for exporting the CSV file. Then you could also interpret the EMG record. So the main thing was allow the user to simply interpret the model signals from what was recorded. So after doing the experiment, we said we recruited 3 individuals to perform this experiment, to determine the model strength here. So after doing the experiment here, we were able to get these 2 things here. So here we have a patient that has weak muscles and a patient that has strong muscles. Now I already mentioned to you that there are certain parameters that will determine that this patient has weak muscles and this patient has stronger muscles. So here, from the computation that has done in our single window, you can able to display that here the patient will have weak muscles, and this one here. Now, what is the rationale? The thing is that for patients who may have neuromuscular diseases, the clinicians may want to be able to see and determine the strength of muscles and how the patient is responding to treatment. But because these standard-based EMG sensors are very expensive, and they do not also provide the functionality of able to determine the strength of the muscles in real time based on certain parameters. That's why I said that that's the novelty of this. We're trying to see how a low-cost EMG sensor can be able to determine the muscle strength in real time. So here, we just gave you 2 examples of muscles being recorded for weak muscles here and strong muscles from a patient listen. So the main highlights of this research mentioned here was to see how we could fabricate a low-cost EMG sensor connected to an Android app, allow the user to be able to measure the muscle signals in real time and display the strength of the muscles. So either you say, okay, it's strong muscles or weaker muscles, and how the patients are recovering in the process. So the design system, why we design the system allows you to display the strength of the muscles into these 2 categories. However, there are limitations. Like I said, this is still in the design and trying to improve the accuracy. So one limitation is the noise with this trying to see how we could improve the noise, mitigate, so there'll be noise as a result of motion artifacts from patients. So we try to see how we could minimize the noise, and also see how we will to what improve the quality of the noise. So we try to see how we could what improve the quality of noise. In future, what we hope to do is to try to use what dry electrodes. So what we used in our test was just what surface chloride electrodes, which are wet electrodes, and there was some little bit of what distortion is. So what we'll try to do in future to see how we could what improve this design and what the accuracy. So just to sum up, I know that you have all been given 10 minutes to do. Just to sum up, we're saying that the Maya system is a useful thing, and we hope to improve it and to see how we can use it to determine the model strength in real time, and as well try to see how this can be used in the clinical setting. So it will be very useful for patients in the care home here in the UK, or people who are maybe undergoing rehabilitation. So try to see how the sensor can be able to assist patients who are undergoing some form of muscle muscle issues and who are undergoing rehabilitation problems. So this is basically the summary of what we try to do in designing this low-cost EMG sensor to measure models. And this is my presentation. Thank you.
Well, thank you, Anthony Baba, for your wonderful research work. So, just wanted to understand, like, what is the cost of development which occurred for you, and you have mentioned it as a low cost. So, what is the actual equipment cost, and how much would this cost?
So what we aim to design it to be something in the region of less than a few, okay, so let's say in the average of £100 or so. And the novelty, like I mentioned, try to see is that with this sensor, we want to be able to set this parameter to be able to determine the model strength. The standard-based EMG sensor they just allow you to measure models, but they are unable to interpret it. For example, just like the BP apparatus, blood pressure apparatus, able to measure your BP and give you something, we realize that there's nothing like that when it comes to measure. So, for example, how do you know that, okay, a patient who have muscular disease, this one has fatigue muscles, or this one, maybe based on the treatment, this person has stronger muscles. So that's one of the things that came to mind. But in our design, we aim to get something very cheap in the range of £100, which is much affordable compared to the traditional Adventist sensor. That's almost like over £10,000 here in the UK.
Okay, wonderful. Thank you.
All right, thank you very much.
Material or present cost of the equipment which are there in the market.
Sorry, come again.
The cost of the equipment in the market.
You mean the material that we are using to design? Because if it's the material that we are using to design, we said that very cheap here, because I think I skipped here. So for example, here we said that this is just in the region of £5 here. So this malware itself, this two here, and this one also 5. But there are some other components there that we need. And here too, we realize that for the main power source, we may not be able to use this in the area. So we're trying to see how we could find some better power source to be able to power this device. So those things will all go into the design. But like I said, the aim is to have a very simple low-cost sensor. And if we think that of all the design, everything should sum up to average £100, that should be affordable.
Thanks for introducing me. Ladies and gentlemen, I would like to present on the topic of identification and mitigation of mismatch latent defects for effective sustainability practices implementation in Hong Kong's high-rise residential buildings. So we have a team of 4 staff. Here show us the outline. We would like to share with you the introduction and an overview of sustainability practices in high-rise residential buildings. And then we try to give you a methodology, potentials of the main premise design scheme, and the results of our research. Here show us the objectives of the study. First of all, we would like to discover latent defects in high-rise residential buildings and try to highlight expert perspectives on building end user requirements. And we try to scrutinize the most significant latent defects and with the hope of enhancing building end user satisfaction and comfort. Here shows us the introduction of our research. We would like to share with you an overview of sustainability practices in high-rise residential buildings. Defects are always discovered only after the occupation stage are referred to as latent defects, which are rarely identified during the construction stage, and thus building designers and developers rarely account for them. We would like to eliminate latent building defects, which is quite difficult, as most latent defects become obvious 2 years after occupation. So that's why we would like to prevent those latent defects from their actual occurrence. Here show us how we can identify the latent defects. So first of all, we can identify from poor design, which may lead to latent defects, but they are rarely identified during the construction stage, which can only be identified after occupancy, and therefore building maintenance is needed. On your right-hand side, we may see those latent defects in our research, which are due to mismatch from number 1 to number 23. That can be identified from our literature review as well as experts' information. What our experts in literature review said: inadequate information, awareness, wrong assumption, and the lack of knowledge contribute to latent defects at the design stage. Up to about 58% of the defects are originated from faulty design, of which misjudgment of users' intended use is an important factor. Defects due to faulty design will appear during the occupancy stage only, and faulty design generally causes more latent defects than workmanship, generating many maintenance problems. Hence, it is badly needed for us to avoid those latent defects. The decisions of building designers have an impact on the sustainability and life cycle costs of the buildings. A majority of building maintenance is caused by poor design. With better design, definitely we can avoid latent defects. Why do we need our study? Currently, there is no effective feedback system in the development of high-rise residential buildings in Hong Kong, allowing building owners and management staff to reflect end-user requirements and maintenance problems to building designers, which may lead to the reiteration of faulty design. That's why we try to identify the latent defects associated with a mismatch between designs and actual end-user requirements in high-rise residential buildings. Leveraging this information, we can develop so-called relevant end-user-oriented designs EOD cloud-based platform. The data can be transformed for sustainable high-rise residential building development in the form of a cloud-based EOD platform, facilitating proper appraisal of project designs, which can engage our designers and stakeholders as early as the planning and design stage, gathering post-occupancy feedback and incorporating necessary feedback into future designs. So with the use of the data, we should be able to develop our cloud-based EOD platform. What is Plan Managed Design Scheme? In the design phase on our right-hand side, so left-hand side, we can see here show us the essential outfit, which can only include it in our design. Therefore, unnecessary building amenities should be avoided. If we can collaborate with stakeholders, we can identify and eliminate efficiency and unnecessary costs with a view to minimizing waste and maximizing values. How can we do the research? We would like to make use of that survey with research professionals, and additional extend literature review and content analysis. We adopt David technique, and the responses can be collated across 2 rounds of David survey using the following techniques: mean ranking, significant index, and inter-rater agreement statistics. In terms of the methodology, we try to make use of statistics, so-called David technique, to identify the latent defects. We make use of IRA to emphasize express viewpoints on building and user requirements. We make use of Cantor coefficient to measure the concordance between the correspondence. Therefore, 2 rounds of Delphi survey is pretty good enough. In terms of the depth survey, that's to be conducted across 2 rounds, and then we try to make use of mean ranking, significant index, and IRS statistics to analyze the results. With the use of depth survey with industry professionals, this technique was chosen on the following grounds. Only experts can provide quality response to our questionnaire. It allows for different opinions from experts. It serves as a better substitute for such physical meeting where decisions can be influenced by pressure to agree on the spot. Group decisions from experts are better than individual decisions from professionals. Quality is always more important than the quantity of experts. With the use of depth survey with industry professionals, we have invited experts based on the predetermined criteria. They should have experience in our construction industry and in the individual involvement in high-rise buildings should be involved. In terms of the depth technique, we would like to make use of the expert quality response because decision cannot be influenced by pressure to agree on the spot. So we try to come to a consensus on differing experts' opinions and then try to come up with good decisions from experts. Bearing in mind that quality is always better than quantity. We also have used IRA statistics and then try to come up with the solutions. In terms of the depth survey, so there are altogether contractors, consultants, and clients. And on the left-hand side, we can see about 1/4 of the respondents come from engineer. We also have building developers and researchers. And designers such as architects also play an important role, which had a weighting of about 1/5 of the overall responses. How about the second round? On the bottom, we can see about 1/5 of the respondents are architects, followed by project managers. We also have the researchers as well as the engineers. On our right-hand side, we can see most experts have experienced more than 25 years, as shown from the bar charts on the below bottom. Experiencing and demonstrating good experience from our so-called experts. Here show us the results. We would like to identify the latent defects in Hong Kong high-rise residential buildings. Carpet alpha coefficient alpha is among the most often utilized measures of internal consistency. According to the researcher, the statistic should have a carpet alpha coefficient greater than 0.7. And the alpha value for the first round can be up to 0.965, which is far greater than the threshold. And alpha values were 0.6967, 0.9676 for both academics and client groups, and 0.965 for the contractor group as well. So here the table shows us the agreement analysis, and most of the results can be agreed on among our experts. In terms of the significance of latent defects, we can make use of those measures. Less than 1.5, not important. Between 1.51 and 2.5, somewhat important. Important, very important, and if we can have score greater than 4.5, extremely important. So this table shows us the result of the first round, as well as the second round. And we should be able to identify the latent defects. Out of the 23 identified common latent defects associated with the design of high-rise residential buildings, 4 defects were granted as somewhat important. 16 important, 3 very important. So this table shows us a summary of those latent defects identified as important, somewhat important, and very important. And we also have made use of inter-rater analysis to share with the correspondence and concordance analysis among the respondents between the first round and the second round depth survey. And the top latent defects were identified as follows: external pipes inconvenient for maintenance, poor curtain wall design leading to difficult access for maintenance, inadequate working drawings and specifications. To conclude, we would like to suggest an external pipe crucial component of a building's plumbing system. However, if it is not situated correctly, it can create significant maintenance issues. One challenge with external pipes is their accessibility, making it difficult for maintenance professionals to clean and report them. That's why we have to plan it as early as in the design stage. Curtain walls are essential for modern architecture, providing impressive aesthetics and energy efficiency. So poorly designed curtain wallings can lead to significant maintenance issues. What's more, inadequate working drawings and specifications can lead to a range of latent defects in the building. And on the other side, we have identified the critical latent defects in high-rise residential buildings, including external pipes, poor curtain wall designs, and insufficient working drawings and specifications. Therefore, both architects and engineers should create designs that prioritize end-user satisfaction and comfort, which is actually the aim of our research study. Here are the references for you to refer to if you are interested. And that's the end for my presentation today. Thank you for listening.
Good afternoon, everyone. I am Mitra Trikurasma, co-author of this paper, that is Historical Evolution of Digital Electronics. Basically, this one is the review paper. Next slide, please. Next slide, please. Okay, thank you. These are the introduction of our review paper. That is, digital electronics is a branch of electronics which deals with digital format of data and code. So, digital electronic system use a digital signal that are composed of mathematical feature to work. So one as here consider one as true and zero as false are called bits, and group of bits are called as bytes. Digital electronics have application as computer communication and control system. Field studies in digital circuits include logic gate, digital filter, flip-flop, and Boolean algebra. Next slide, please. Here some logic gate are shown. That is called AND gate, OR gate, NOT gate, NAND gate, NOR, XOR. Basically, this is the review paper. So in that we have considered these are the gates basic are used for the digital electronics. So I have one by one showing the gates that A and B. So there are the tables shown that is called truth table. So based on that, bytes will be considered like A and B, that is 000. So one by one, you can see that all combinations are here like that OR gate. So A or B, that is 000, 011. That are the OR gate. This is the NOT gate. NOT means 0, not A means 1, 10. And NOR and similarly XOR gate is shown. These are the combinations used for designing the digital electronic circuits. Next slide, please. So here digital filters are shown with some example. Here one original signal, that is complex signal, has been taken as a reference, and from that there are the three frequency component shown in that this signal. Consider, and they are passing through different of type of filter, and you can see the different type of outputs by using. These are the, if you see first frequency pass through low pass filter, that you see some band is set. So accordingly that signal is filtered. So basically the purpose of digital filter is to identify some special component of the frequency. Next slide, please. These are the flip-flop. Flip-flop is a sequential digital electronic circuit with two stable states that can store 1 bit or binary data. 1 bit of binary data. Flip-flops are the fundamental building block of all memory devices. You can see here the that circuit also. Now next is Boolean algebra. Boolean algebra can be defined as a type of algebra that performs logical operation on binary variables. These variables give the truth tables that can be represented either by 0 or 1. Like previously, we can show by that get also. There are three basic Boolean algebra operations. These are conjunction, disjunction, and negation. The equivalent logical operators to these operations are given below. AND operator, it is analogous to conjunction. In a Boolean expression, dot is used to represent the AND operator. This operator returns true if and only if all input operands are true. Second one is OR operator. This operator is equivalent to disjunction. In a Boolean expression, plus symbol is used to represent the OR operator. The operator returns true if and only if one or more of the input operands are true. Last one is the NOT operator. This logical operator is comparable to negation. NOT operator returns true if the input variable is false. Similarly, if the input variable is false, it returns true. An overline on the variable is used to represent this operator. Next slide, please. So here, two signals are shown. One is the analog signal. You can see the variation of the frequency, and one is the digital signal that is passed through filters. So that is the basic use of digital filters. That is the filter out the unrelatable frequency. Next slide, please. So conclusion of this review paper, that is, digital electronics engineering is crucial and significant in the current technology advanced society. The fundamental ideas that enable effective information processing, precise control, and seamless communication in digital systems give rise to its relevance. Our efforts in this piece enable us to develop and fabricate complex digital circuits, microprocessors, microcontrollers that fuel innovation across various industries like telecommunication, consumer goods, automobiles, the military, and the healthcare rely significantly on digital goods engineering. Right now, I can give you the one example of solar industry, where we can use the solar cells, in which some digital circuits, like right now, we have far away from this IGBT devices are used for switching of that controller. Digital electronics engineering will continue to be an forefront as we push the limits of technological development, allowing us to create a digital future that is more effective, networked, and equipped to meet the expanding needs of our society. Thank you for my presentation is over now. Thank you.
Thank you so much. I'm Kalishwari from Malaysia. I'm going to present about a study using a semi-structured interview to explore the current practices to curb obesity among secondary school students in Malaysia. Actually, I used a qualitative study. So moving on to the introduction. A child is considered obese if the BMI is actually more than 2 standard deviations. And then according to the systematic review done in Malaysia, we had increasing rate of obesity cases among adolescents. And according to research done, Malaysia actually embraced the highest position in obesity ranking in Southeast Asian country. And according to our National Health Morbidity Survey 2019, 50.1% of adult population is overweight. Among them, 14.8% children are basically overweight in Malaysia. So appropriate measures were basically taken to prevent these obesity issues among school children. And what was the data collection method I used? Actually, basically, I used semi-structured interview. You can see those 9 stages. I'm not going to go through the 9 stages. And then the data was analyzed using thematic analysis, which has 6 stages. And I have incorporated 2 teachers, 2 parents, 2 students, and 2 health officials to ensure that I have data triangulation to get different sources. And there are 5 major forms of practices, which is food-related practices, school curriculum-related practices, physical activity-related practices, practices to create awareness, and also collaborative efforts between the Ministry of Education and the Ministry of Health. I'm going to start on with the food-related practices. Actually, they were banning all kind of unhealthy foods and beverages to be sold in the school, like those that has high sugar, junk food, snacks, carbonated drinks, and so forth. And they also ensure that healthy food menu is supplied in schools. Those contain fruits and vegetables. And they implement Malaysian food pyramid, whereby students are exposed to different types of food that they need to consume on a daily basis. And they also implement Malaysian healthy plate system, whereby they have this quarter half plate system. Half of the plate consists of fiber containing foods such as fruits and vegetables, quarter carbohydrate sauce, and the other quarter is basically protein sauce. And they also have this food aid program, especially for primary students, students of the age 12 and below. But this food aid program, although it contains healthy food menu, it only for low or middle income group students. And canteen guidelines also available for canteen operators, whereby they have the list of healthy foods they can serve at school. School curriculum practices, on the other hand, we have SIGA, which is the National Physical Fitness Standards for Malaysian school students, which is an assessment to detect obesity or overweight among students using BMI, but it was done irregularly and there's less follow-up actions and programs after the BMI has been recorded. Physical education also there for students, whereby they carry out sports activities for 1 hour. And they do have these teaching and learning processes whereby they learn during science and biology lessons about healthy food, Asian food pyramid, healthy consumption, nutritional value, calorific value, importance of physical activeness, and so forth. And they also have assessment of physical activities, sports, and co-curriculum, whereby it is a compulsory requirement for students to complete this assessment requirement before they enroll into tertiary education. Next, moving on physical activity related practices. Definitely, students are encouraged to do physical activities for at least 3 times in a week, whereby the teachers will basically recommend on how they should carry out the physical activities. And we do have a policy known as one student, one sport policy, in which 1 day in a week is all that selected for students to carry out their favorite choice of sport. And practices to create awareness. There are posters in schools about reducing sugar intake, about taking Malaysian food pyramid, adhering to Malaysian food pyramid, telling students how much they need to take and they need to consume a variety of healthy foods and so forth. And they also have health seminars and talks to expose students on healthy lifestyle and also obesity preventive measures, and healthy eating campaigns focus more on quarter half plate system. And the last one would be definitely collaborative efforts between the Ministry of Education and also Ministry of Health. The banning of selling of prohibited foods is a diet-related practice, but it was a joint effort between Ministry of Education and also Ministry of Health. And district education office in all the states in Malaysia, they must employ a nutritionist so that they can look into nutritional guidelines in schools before they plan and implement that. And they also have school unit at district health clinics in all the states. This school unit work together with schools. It's actually a division under a district health clinic working together with schools to monitor students' health, whereby there will be any students with obesity issues will be referred to doctors, and doctors will basically take history, and then they call in the parents for elaborative counseling, and then they refer to dietitian, and if needed, they refer to pediatrician and so forth. So in conclusion, I would say that we have so many practices in Malaysia. One of it is actually focusing on healthy diet. The other one is actually focusing on promoting physical activeness. Some is actually talking about how to create awareness among students. And there's so much of collaborative efforts and so forth. But we have so many practices, the cases are still uprising. So we need to do further analysis why, despite many practices, we do have cases uprising in Malaysia, especially involving secondary school students. Thank you. Can I continue with the next presentation?
Yes, ma'am.
Can this seen?
No, we are able to see the first one only in the conclusions. I hope
Yes,
you
I'll
just stop.
share again.
Reshare it again.
Okay, factors can be seen. This can be seen.
Yes, a study using semi-structured interview investigate.
Factors.
Yeah.
Okay, factors. So I'm going to talk about childhood obesity in depth. In 2011, the cases were just 6.1% in Malaysia. In 2015, it went up to 11.9%. And the latest review, 2019, 14.8% childhood obesity cases in Malaysia. So one of the reasons is because we do have this prolonged energy imbalance state in Malaysia, where students take excess high-calorie food, and then they do fewer physical activities. Some of the factors would be genetic syndromes, hormone disorders, medications, genetic factors. These 2 genetic genes, which is FTO and also MC4R, these genes are actually interrelated, not related to high energy dense consumption, high energy dense food consumption. And these 2 genes are aggravated by physical inactiveness, prenatal and postnatal influences, such as that when the parents or the mother basically has high BMI value when she is pregnant or so ever, it could affect the child's, the fetus fat metabolism. Parents' restriction also can affect the children eating habits, sedentary behavior, physical inactiveness, like simply watching televisions and not moving their body much, can also cause obesity, and high calorie diet consumption. Those that are sweet, those are containing high amount of fats, can also cause obesity. The same data collection method used, again, it's a qualitative study using semi-structured interview, and the data was analyzed using thematic analysis involving the research participants. Same, I have to include teachers, parents, and students, as well as health officials to get different ideas from different perspectives. And there are 4 factors that leading to obesity, according to the perception, understanding, and also experience based on the interviewees. Environmental factors, dietary factors, sedentary living, and also health-related factors. So environmental factors, it's about, there are several factors. One of it is actually inadequate education in school, where not only students, parents also not getting enough exposure. There are lack of monitoring, no clear guidelines for the students to follow. There's no practical application. And teachers are assessing, teachers are not giving feedback enough, and they're not taking it into nutritionist input when they teach about nutrition. And stress, so much of academic burden for students, and they have so much of public examination, and they have family pressures of achieving higher grades, interpersonal problems, emotional problems leading to stress, and this stress causes them to overeat as a method of coping stress. Mindset, some family members think that overweight is fine. So since most of the family members are overweight, they tend to encourage others to be, to eat more and to be overweight as well. Ineffective SIGA implementation, even though we have SIGA, since it is not regularly done and there's no follow-up actions after the assessment, it kind of causing implementation failure. Peer influence. Students do share lots of ideas, practices, habits together. When these ideas and practices is about unhealthy eating habit, definitely it's going to cause them to follow the unhealthy eating habit and leading to obesity. Lack of posters, not updated. Some schools have posters, some schools do not have posters, some schools have posters but not updated. Lack of awareness campaign. There is no specific team in school to carry out awareness campaign in schools, to organize activities and programs. Lack of healthy food advertisements. Most of the advertisement is about fast foods. Easy access to unhealthy foods. There are so many convenience stores, so many hypermarkets, supermarkets selling frozen foods, processed food and everything. All these are actually easily accessible to the students. There are too much of fast food restaurants blooming in Malaysia. Some of it very close to residential areas, some of it very close to school areas. And this fast food also, they come up with very good home food delivery system and abundant fast food advertisement in mass media. There are a lot of banners and posters along the street where students can get to see it and they get attracted. COVID-19 pandemic also caused a lot of obesity cases to rise up in Malaysia, especially when we have lockdown, we all become inactive, homebound, and so forth. Students' attitude, also another environmental factor, they have lack of discipline, determination, self-direction. If there is no motivation, there is no one to remind them, they will basically never follow any weight management strategies. Parents' attitude would be another reason, lack of cooperation given by the parents, lack of support, and especially they have this tradition of having family dinner together. Whenever they have family dinner, they eat large portion, and then it is not meeting the requirement. A lack of facilities, sometimes equipment, field space are not there in schools, not there in residential areas. Lack of teacher training, especially when government implement new policies, the teachers are not trained well to implement those policies, leading to implementation failure. Economical constraints. Healthy foods are actually very expensive compared to unhealthy foods. So students tend to stack up their home with so much of unhealthy foods. Time constraint would be another reason. Long schooling hours. Some of the students basically are studying until 4:30. So they don't have enough time and they go back home. When they go back home, they have to do tuition, homework, and so forth. So they have no time for them to carry out physical exercise. And lack of collaborative effort. Even though there are some collaborative efforts, they need to be more, because we need to have more seminars and talks in schools to expose students. Next, going on to dietary factors, unhealthy eating habit among students, consumption of fats, sugar, high-calorie food that is present in fast foods, and as well as junk foods. An unhealthy way of meal preparation, cooked with preservatives like MSG, excess use of fats and oil while cooking, skipping meals. Students like to skip breakfast, and then they tend to eat more during other meal hours. And artificial flavors, fats, and artificial colors present in some of the food, kind of causing students to overeat. Unhealthy eating behaviors, such as they eat more than what they need. They eat snacks in between main meals, and then they consume processed foods. They eat genetically modified foods. All this basically causing obesity and imbalanced diet served in school. School is supposed to serve food according to quarter hot plate system, but it is not done in school, and they use more sugar, salt, and oil at school. Canteen operators are given guidelines, but they're not following the guidelines because there is no enough awareness among canteen operators, and you're not getting enough input from nutritionists to plan on diet when it comes to age, gender, and physical activeness. Sedentary living is also causing obesity among children. Using gadgets, playing video games, watching television, listening to music, and a lack of program that promote physical activities like that present in China and Singapore, they incline more towards technology. They have so much of tuition, so much of homework, increasing desk bound behavior, lack of support. They cannot plan daily activities because they don't have someone to sit with them to plan on a personal timetable, to come up with some personal timetable in which they have some slot for them to do some physical activities. And using of gadgets as well, making them so tired of thinking. And this will cause them to eat more, especially junk and sweetened food while playing computer games. Health-related factors would be like genetic predisposition. Genes are actually shared among family members, siblings, and relatives. And there is also lack of medical expertise. No medical officers or dietitians or accesses therapists or pediatrician working with schools closely with parents and students to monitor. And physical hormonal changes during puberty can basically increase appetite. Metabolic, endocrine, and also underlying chronic illness basically can cause obesity as well, such as diabetes mellitus, hyperlipidemia, or thyroid disorders. In conclusion, there are several factors. We can say we have environmental factors, we have sedentary living, and everything can contribute to obesity. The several measures have been taken so far in Malaysia, but I think the practices should focus more on the factors that students can control, such as eating habit and physical activeness. That's all for me. Thank you.
For giving me an opportunity. Let me go through my PPT. Our paper is regarding like insights from medical documents without the document. It is like regarding the it is from the LLM model and as well as the NLP model regarding to that. This research provides doctors with a comprehensive understanding of patients' medical history by enabling access to patient records and prescriptions across countries, regardless of language barriers. It enhances healthcare globally. The main objective is to minimize medication errors and improve outcomes. Informed decisions rely on a vital medical information, making the system crucial for both doctors and patients actually. So in the healthcare sector. Also, this helps in government health policies. For example, if any new or existing disease or anything spreading across countries, the medical information will give an extended support to identify the disease and medical support document or information for other countries as well. So without language, without any language barriers or anything, with in a healthcare kind of patient understanding and also like leading to medical, like preventing some medication errors or something. So this will give a compromise outcomes for that. And here in this research, we are using a large language model based learning and also the advanced natural language processing to develop solutions for accurate medical document translations. And this research aims to revolutionize our patient care, enhance adherence to treatment plans, and create a more inclusive healthcare system. And here, the proposed approach involves following steps for the multilingual translation problem. Here, we are using OSIA and data pre-processing in that NLTK, GenSim, and SPACY libraries. And also NER and large language model we are using. And also at the last, finally, we are using the language translation model. So actually in the architecture, in this architecture, we can be able to understand what I'm trying to say. So, and before that, I just want to give an introduction about NER as well. NER is just like a most popular data pre-processing task. Actually, it involves the identification of key information in the text and classification into a set of predefined categories. And an entity is just basically a thing it is consistently talked about or referred to in the text. NER is form of NLP actually, and its core NLP is just a two process. It was involved in like detecting the entities from the text and also classifying them into different categories. And so it is kind of like some of the categories that are most important architecture in NER, such as like person, organization, or any place, some kind of. And other common tests like task are involving in the classification such as some date, time, expression, and something. So numerical measurement and email address, so these kind of things. And the architecture, I will go through this. So Okay, actually here like we can use any medical documents in an like UI or image, actually, like any prescription or any medical documents for any like some patient history or something. So the OCR recognizer is a technology for text extraction. It helps to identify the text from the image, and it will helps me to convert the data to the unstructured text data, actually. And then we will do the pre-processing steps such as stemming, lemmatization, etc., and passing through the NER model. So the NER model, I have just told you, like it will give us the entities, attributes, and kind of things, and we'll be getting the responses and entity, attributes, objects. So from that we can able to feed or process the response in the LLM GPT-4 model. So that helps in response with whatever solution we need for the particular business problem. So the final response we will be getting it to the translation models like Embed. So this gives a response in a native language. So that we asked, actually. So like what like so yeah, like all person didn't know like what like all languages in the country, actually. So this translation model will helps to like convert some any languages or English or anything to our native language, so that we can able to understand easily. So the summary like summary of any like documents, like history documents or something, that we can able to understand, and it is very much helpful for the end user. So the next slide. And here, actually, we have used this much like NER models here, and in course iistem and in course MD and LG. So this many models we have compared. From that, we got only the like 0.92, like 92% accuracy from here. It's like how I'm saying, like we have processed 100 questions in an input in several NER models and asked for a response from the LLM models. Only from the LG model, we got the better response as like 90 out of 100 like valid response we got from the like from this model. So LG, so from the better response and as well as accuracy, we are concluding with the LG model is giving the better accuracy. So in conclusion, research approach this study involves like novel methods using like large language model. Actually, we are using LLM and NLP to accurately translate, and it will helps to like understand the medical documents for any end user, like if there is any like if they are approaching any new doctors in any other countries, so that they will help, like it helps to like breaking down the language barriers to understand the patient's medical information and everything.